This video is for 7805 ICT Principles of Software Engineering, and I'll demonstrate the Minesweeper project Milestone 3. To start this video, I'll go through task 1 to 3 first. Task 1 was to implement the standard Minesweeper game, and the game has been built successfully with full functionalities. So I'll firstly show you a quick demonstration of task 1. So when you enter the game, you will see the menu screen. So on the menu, you can choose different levels and also to switch between which version of Minesweeper you want to play. So just for this video, I'll start with the easy one. So on here, there will be 3 mines hidden on this gaming panel. So 1 means there will be only 1 mine hidden around this block. So I'll mark a flag here. Let's try our luck. Okay, so that's the 3 mines, 1, 2, 3 for this game, and the other blocks are blank. So by clicking the smiley face, we can restart the game again. So once the smiley face changed to sunglass version, then the game means it has won. The user has won the game. So the timer here represents the score, which is 9 seconds here. Okay, stop running the game. So with task 1, the timer will start when the user has made a mouse click movement on the gaming board, and also the layout will be implemented similar throughout other versions of game. So that's the screenshot. Task 2 was to build a hex mine. So with hex mine, it's incorporated into the same software with task 1, so making the 2 versions cross-platform. Same with classic Minesweeper in task 1. The hex mine has the smiley face here, and it also plays a very similar gaming logic. So do a quick demonstration of task 2. So switching to the hex version, still let's do a easier one. So the timer doesn't stop until I make the first movement. Yep, it starts. Okay, so 3 means it should only be 3 mines on this game. Yeah, so the game has won. So the logic is that if the block says 1, it means there could only be 1 mine hidden surrounding itself. So the game always comes with background music, but I've turned it off for this video purpose. Okay, so task 3 was to implement the colorboard Minesweeper. Unfortunately, due to time constraint, task 3 wasn't be able to be completed with full functionality. Therefore, I didn't implement into this software. So the Minesweeper project comes with the 2 versions at the moment and 3 levels. Level 3 simply means there's more mines hidden and it's harder to win. So next, the cross-platform. So Minesweeper project is a cross-platform for task 1 and 2. Users can click the plus and minus button as shown on here, and I've demonstrated before how to switch between different versions of games. Level 1 just means less mines hidden on the game, level 2 6 mines, and level 3 9 mines. And the same difficulty applies to 2 versions of the game. Next, I'll go through the objectives 1 to 10. So firstly, design principles. The development of Minesweeper project has followed several design principles. This ensures the software is safe and then also reduce the chance for errors to occur. Firstly, the principle of least privilege. This ensures the information security aspect to the software. So Minesweeper game does not require any root privilege to be run. It simply just offers the user a limited amount of buttons, and also there will be not any sensitive data to be saved. Even the score will not be saved on this game. It's an offline version game and it can only be played by one player at each time. The next principle we followed is the fail-safe defaults. So this has been considered where the default permission for any object is no access. So for the Minesweeper game, there will be not any need to access the source file in order to run the game. The game will be simply run by Pygame, and the user is only limited to these buttons. The separation of concern is also considered when designing the two functions of classical Minesweeper and the Hex Mines. While these two games share the same game, the next principle we followed is the separation of concern. This is considered when designing the two functions for classical Minesweeper and Hex Mine. So these two versions of game have the same game window, the same start menu, and the internal structure and design of one version of game does not impact or affect the other. So the gaming logic is separate while they share the same menu functionality here. Information hiding has been applied to each module so they can be used without the knowledge of detailed implementation in the code. So we've had the normal mine here and also the hex one, and they both use the gaming logic in here. Encapsulation also has been used to prevent data from being called accidentally. This is achieved by adding underscore before the variable name in Python. Low coupling and high cohesion can reduce module complexity and increase maintainability. Therefore, during the design of Minesweeper project, modules and functions are loosely coupled, so changing one class of functions does not affect another. For example, changing the function of classical Minesweeper, which is this one, will not affect the hex mine. And changing the functions of restart button and timing functions does not impact the gaming logic itself. So two functionalities are separate here, but they are still interconnected to be used each other. Second objective is design process. Design process for Minesweeper project has followed a top-down design process. So firstly, start with the interface design. So in Milestone 1, a GUI prototype was created to explore the interaction between the environment and the system. There was also a quick black box testing involved to examine the completeness of functionality of the prototype in Milestone 1. Followed by the architecture design, the project goes to the architecture design process, where each component is analyzed and reviewed to make sure the responsibilities and the communications are correct. For this design, we used class diagrams to assist with creating classes for the program, and also the non-functionalities requirements were considered during this phase of design. Lastly, detailed design is to actually implement the code to design the gaming logic and also to construct the game menu, buttons, input, output for each functions. For this process, dynamic models and structure models were created to further examine the behaviors between objects and within the Minesweeper system. So this is the class diagram, and sequence diagram is the dynamic model, followed by the use case diagram. As you can see, when the user hits the Minesweeper system, it has to go through the start menu, choosing the game level and game version. Once the game starts, the user can click on the game grid either left or right click, and then it will either review the bomb or review a blank block. When the game is over, the timer will stop and the user can start the game again. Objective 3 is the system models. As mentioned above, there were several system models created for the structure and behavior of the Minesweeper project. So we start with the activity diagram in figure 1. This is to analyze the dynamic features of the system, also analyze the flow of the game. It will help with writing the code for functions in this game. Also, the diamond shape notation in activity diagram represents the decision and alternative flow, and this will assist the development to code the if and else condition. Followed by the static model, which is we've discussed before, the class diagram, and also dynamic model use case diagram. Objective 4 is for the design of Minesweeper software. It's been built with programming language Python. It used the object-oriented programming paradigm to make properties and behaviors into individual objects. For example, the class of MineBlock. This is responsible for getting the action of users. So on here, so whether the user has clicked on a block that has mine or if it's empty, this will calculate the relevant reaction. And it needs to set the status of the block. Both the classic and hex mine will inherit those functions in this class. For software architecture, there are many software architectures patterns we can choose from to assist with the software development process. Firstly, we have the 3-layered architecture, but this is more suitable for complex business applications, and it will have a more focus on the database. This game does not have any huge database to be run. It's a simple offline game, therefore this software architecture model was not selected. Other patterns are the client-server architecture. Again, this one is more suitable for web applications, which involves servers on the internet. So being an offline game, we did not choose this one. So the Minesweeper project has selected the model view controller architecture model. This is one of the most common models, and it's very popular to be used for many software development. This helps to map the input, output, and processing of roles of a system. The Minesweeper project relies heavily on the GUI to be run. The Minesweeper project relies heavily on the user interface to interact with the user. As you can see, the user will input to the controller, and the model will manipulate and update the GUI to the view, which is the GUI, and represent this to the user. So this architecture pattern helps to separate input logic, business logic, and the UI logic, and this allowed the modification to be easier. Objective 6 is the design pattern. The Minesweeper software has creational design pattern, and this pattern helps to create reusable object-oriented software. By using this pattern, the objects in the Minesweeper software will be easier to change, test, and reuse, and also reduce the repeated code by proving a way to create abstract objects, then use the interface of the abstract object to create concrete objects. The user interface software using event-driven design for Minesweeper project. So the Minesweeper program responds differently depending on different events. So these events are simply users' actions, such as right-click on the game or left-click on the game. The GUI was completed first. After placing all the buttons on the GUI interface, the functions are then implemented to each button according to the software requirements. Model View Controller to Interface Programming. As discussed before, Model View Controller was selected as the architecture pattern. The Model View Controller can be broken down into 3 interconnected parts. So it's the model, controller, and view. So for Objective 9, Properties of Good Software Design. So good software design will have the qualities including maintainability, correctness, security, reliability, reusability, and reusable. At the same time, it must meet all the functional and non-functional requirements, which we have indicated in Milestone 1. So with this Minesweeper project, it has also followed the many software design principles, and we've discussed in the Objective 1. So this ensures the quality of the program and reduces likelihood for errors to occur. The project also has included sufficient and reasonable commenting in the source code. So this will provide a clarity for other programmers to understand this code and making this code reusable and easier to upgrade in the future. Lastly, the project provides reliability and correctness. All the functional and non-functional requirements that were designed in Milestone 1 has been implemented into the 2 versions of game. The program runs as expected with no bugs, and it's easy for users to understand and operate to navigate. Finally, the design documentation. Throughout the development of this project, there have been many design documents created for different stakeholders. These documents will assist developers to understand the business requirement and to review the source code in the event of a bug or design problems. Software documentation also helps to record the design logic of the whole program and helps other developers to maintain and doing other upgrades in the future. So here I've simply listed the different types of documentation I've used. First is the requirement documentation in Milestone 1 that includes the functional and non-functional requirements. Next is the architecture and design documentation. This is the UML, which includes dynamic models and static models, use cases. The third type is the technical documentation. There hasn't been a complete document written for the software's code, but sufficient commenting in the source code has been added for the technical developers to understand the program. Finally, version control has also been used to manage this project by using Bitbucket. So as you can see, I've been using Bitbucket for other courses as well. So for the Minesweeper project, here is all the files, and that's a log of the Bitbucket. So that's everything for demonstration for Milestone 3. Thank you.